Hello friends, welcome to chemistry lecture paper 3. In my last lecture, we have seen the types of gravimetric analysis and the factors affecting the solubility. Today we are going to see the various operations involved in gravimetric analysis or unit operations involved in gravimetric analysis. Now see, the unit operations involved are, first one is precipitation, then is digestion. This digestion is also called ostoal ripening or aging, even you can call it. Then comes filtration, then comes drying, then ignition or incineration, and sixth one is weighing. Or here we can write even heating. Or incineration, and then sixth one is this. Now see, the minimum condition for precipitation is your ionic product of the solid should be greater than solubility product. Now when the solid starts separating from the solution, it is in the form of small particle. These particles are called nuclei, and the process is called nucleation, and rate of formation of nuclei is called as rate of nucleation. After this nucleus is formed, then the salt keeps on depositing on that nucleus, and that is called as growth of crystal. And the rate is called as rate of growth of crystal. Now see, means precipitation involves two processes, that is nucleation and growth of crystal. Now suppose if rate of nucleation is small and rate of growth of crystal is large, what will happen? Small number of large particles would be formed. Now, if your rate of growth of crystal is more, then reverse would be the case. Large number of small particles are formed. But see, if large particle size is large, it increases the filterability. Hence, this is preferred. Now see, as the precipitation starts, then various factors such as temperature, solubility, all those plays a role. So, P. von Wieman, he was the one who correlated all the three factors and found the term relative supersaturation. Q minus S upon S. Q is the concentration when there is excess of reagent, and S is the normal solubility of the substance which is formed. Now see, this for precipitation, this Q minus S upon S should be as small as possible. So now we will see colloidal state. Or colloidal particles. Or you can say colloids. Now they have the size between, you can say, 10 raised to minus 9 to 10 raised to minus 6 meters. Means between the crystalloids and coarse particle. Alright, first one is your say nuclei, then you have the cluster, then you have the colloid, and then you have the coarse particle. Alright, now second thing in crystalloids is they show a continuous motion which is called as Brownian motion. Third thing, these colloids are charged particle because they adsorb particle. They scatter light. Which is called as Tyndall effect. Now see, these, when they are in electric field, they migrate towards one ion. Then this can be, if the size is small, they will, if the size become large, they get coagulated. And they can be neutralized by adding an electrolyte. If the size becomes small, they can go into the solution, and this is called as peptization. And to avoid peptization, we need to maintain the size of this. So this was about colloidal state and colloids. Next is digestion. Now, digestion is a process of heating the precipitate in water bath to grow the crystal size or to grow the size of the precipitate. Now see, this precipitate grows in size through digestion. So first of all, it is for growth of particle size. Then it also removes the adsorbed impurity on it. Also, volatile impurity can be removed. Then apart from this, the shape of the crystal is maintained, or proper shape is it gains, it increases the filterability. Now next is filtration. Filtration can be done either using filter paper or Whatman filter paper number 41, 42, or with Gooch crucible, sintered glass crucible can be used to filter the solution. Then after filtration it is drying, after filtration it is washing. Then drying or drying, heating, all those things. So washing we will see in our next lecture. Thank you very much.